All right, now we're gonna try another optimization problem that's very popular. This would be like the volume of some kind of box. And the biggest thing is drawing this, right? They're telling you an open box is being constructed from a piece of sheet metal that's 18 inches by 30. All right, when we do this, you first construct that 18 by 30. That's the first information they give you. By cutting out squares of equal size. So they're saying we're going to cut these little pieces here and we're going to fold the box up, and that's going to create a certain volume. And they're asking you what size square should be cut to make a box of maximum value. So again, you could kind of envision if we were to cut bigger pieces, you're getting a taller box, right? But again, you're taking a little bit of that area underneath. So there's a balance we have here. There's a little balance, and it's just like, what's the best one? Well, we're going to first start out with what's the equation of the volume formula? Well, for volume, we need length, width, and height. Okay, the first one, we know that we're cutting out the box, and that's going to give us height is going to be our x, because that's the piece we're going to fold up, right? We know that one of the sides is 18, and those 18 inches, you can't put 18 on it though. You have to make it into equation. If you see, this 18 side is going to be 18 minus 2x, because you have two sides that you're taking away, right? By cutting it and unfolding the paper up. So it's going to be 18 minus 2x. You leave it as x because we don't know what x is. We're trying to find all the possible x's and then maximize it. So same kind of logic goes for the side that is 30 inches long. Okay, and now we have the volume formula. Let's make this a little bit easier for us to solve. I'm just going to simplify this out, multiply it out, FOIL method, and you end up getting 4x cubed plus 96x squared plus 540x, okay? And remember, they want us to maximize it. So we know we're going to take the derivative. And by the way, if you look at this function, it's a cubic function. Again, you're probably going to have something like this, right? And we want to find that point. And again, it's going to be a little bit different. Maybe it's going to be on this side, all right? And we want something like that. And you're like, wait, what? But wouldn't that be a maximum? We could discuss that later, but just kind of think of the box. If you keep making your x greater and greater, at some point, you're not going to have any more area. So technically, you can only look at the domain in a certain section. You can't look at all of the domain of this function. All right, so we go ahead and get the derivative. That's going to give us 12x squared plus 192x plus 540, okay? You're going to make that equal to 0. And you also notice that maybe there's something that you could factor here, right? They're all even numbers. I could make these numbers a little bit easier. After exploring, I realized that I could factor a 12 from these terms. And that's going to make the problem a little bit more manageable, okay? A little bit more manageable. So right there, now I get this quadratic formula. And you're probably asking yourself, what two numbers multiply to 45 and add to 16, right? And maybe you could factor it, maybe you can't. You would have to just try different numbers. I'm thinking 9 times 5 is 45, but 9 plus 5 is 14, so that's not going to work. So you could maybe do quadratic formula as well, right? You got quadratic formula. You could try to factor. There's completing the square. That's one that works. So if I look at this, by the way, I think I'm already making a mistake here. So go, I just caught it. I'm glad I caught it right now. go back and change. This is supposed to be a negative term, right? I'm going to put it in red. This is supposed to be a negative term here, okay? So all of these should be negative, okay? Glad I caught that right now. That would have been a waste of recording. So anyways, if I look at this equation, I'm thinking, what can I add? What can I add or what can I do to make this into a perfect square, all right? And I'm thinking, well, 16, if I have two 16s, right? Sorry, if I have a 16, I could break that 16 up into 8 and 8. And then I could ask myself, well, negative 8 plus negative 8 is negative 16. And 8 times 8 is going to be 64. And that would give me a perfect square. So what I'm going to do is I'm going to add 64, okay? But remember, when you add 64, to complete the square, you also have to subtract it. So it's kind of like you're adding nothing in this case, right? But you're gonna see what's happening right here. All right. When I add 64, I also have to subtract it. This is called completing the square method. And how do I get that 64? You're normally thinking of a C that is gonna be b divided by 2, and you're gonna square that. All right, in case you guys forgot that. That's how I get that value 64. Okay. And now I see that this is a quadratic and it's gonna be a perfect square quadratic. So I could actually factor that out as x minus 8 squared. Okay. But you still have to deal with that 45 and 64 that you got. So you're gonna be left with negative 19 is equal to 0 or whatever. Put it on this side if you like. Same difference. And now you just solve for x. Well, to solve for x, I'm going to add 19 to both sides. I'm left with x minus 8 squared is equal to 19. And then I'm going to square root both sides. So now I'm left with x minus 8 is equal to plus or minus the square root of 19. And x is going to be my final answer. It's going to be x is 8 plus or minus the square root of 19. And again, if you look at the domain, you actually only want to look at the bottom one. X is equal to 8 minus the square root of 19. All right. This is the only one that's going to be in our domain. And again, our domain is going to be somewhere between 0, where x, right, we need to be a little greater than 0. But again, you cannot make x greater than 9. Now think about it. I cannot have x's here that are 9 because this is 18, right? So if one x is 9 and the other x is 9, well, we're not going to have a box anymore because now it doesn't have any base. Okay, so we look at this one. This is the one that fits in there. And that was a whole reference back to how your graph's going to look, right? Just going back to that. So we found our x. And this x is approximately, plug that in the calculator, 3.641, okay? Now, we have our x, and that x tells us where we have the maximum volume. So now you're just going to plug that number in, okay? You got to plug that number into your original equation. And if you plug that number in, if you want to be more precise, you could do, again, explain it this way, or 3.641. And that's going to give us an approximate volume of 886.5 cubic inches, right? And this would be by maximizing, by cutting squares that are 8 minus the square root of 19 inches, or about 3.64 inches, okay? And again, we could draw kind of like this little graph. How do we know that's a max? Well, if you plug in a number that's less than 3.61 for your x, you get a positive value. If you plug in a number greater than that, it's negative. So the graph is decreasing, which tells you that there's a max right there. Okay, that's kind of like the evidence behind it. All right, hopefully this makes a lot of sense.